Year 7 Pi, question number 19. Patrick is going to visit his aunt in hospital. The visiting hours are from 4 p.m. to 5:30 p.m. The graph shows his car journey from his home to the hospital. So we have a distance time graph, distance on the y-axis, time on the x-axis. How far is the hospital from Patrick's home? So Patrick sets off. We can see distance on the y-axis. When he eventually gets to the hospital, the total distance that Patrick has travelled when he gets to the hospital is 250 kilometers. Part B. What happened between 2 p.m. and 3 p.m.? Now 2 p.m. in 24-hour clock is 14 o'clock, and 3 p.m. is 1500 hours. So between 2 p.m. and 3 p.m. you will see that there's just a flat horizontal line, which means that the distance didn't increase, the distance stayed the same. So if we were explaining in words what's happened, we could say that he stopped for a rest, he stopped moving, something like that. Okay, part C. After 3 p.m. he drove more quickly. How can you tell this from the graph? Now, when you look at a graph, you will find that the graph after 3 p.m. is steeper than the graph before 3 p.m. So it has a higher gradient, and the steepness of the line tells us how fast we are going on a distance time graph. So he drove more quickly. How can you tell this from the graph? So the simple answer is that the line is steeper after 3 p.m. Okay, part D. Did he arrive on time for visiting hours? Now, visiting hours were starting at 4 p.m. Now, did he arrive by 4 p.m.? If we look at the graph, I'm just going to zoom in a bit to make it clear. Now, 4 p.m. there, we can see that he did not arrive on time. He arrived just after 4 p.m. So did he arrive on time for visiting hours? We would say no. How many minutes early or late was he? Now it's hard to be absolutely accurate. There's 4 o'clock, there's 5 o'clock. Is about there. What fraction of an hour would that little bit be to there? I'd say maybe about a fifth, maybe a sixth, or we would call it about 10 minutes. So it's just an estimate, but I would say he was approximately 10 minutes late. I think we'd allow quite a lot of variation on that one. You could have said 5 minutes, 15 minutes, it'd probably still be acceptable. Okay, part E. Coming home, Patrick drove steadily at an average speed of 100 kilometers per hour without stopping. Draw his return journey on the graph. So he's going to return home at an average speed of 100 kilometers per hour without stopping. We're going to draw his return journey on the graph. Now, if he's going to travel 100 kilometers per hour, he has to travel 250 kilometers altogether. So I know that 100 kilometers will take 1 hour, 200 kilometers will take 2 hours, then another 50 kilometers should take half an hour. So it's going to take 2.5 hours for him to get home. So at the moment it's about 5:30. So 2.5 hours, that's half an hour, 1 hour, 2 hour. The graph should look like that. So for part E, that's what you should get. Finally, for part F, what time did he arrive home? We can see on the graph that he arrives home at 2000 hours or 8 p.m.